everyone. It's great to be able to present our paper, Adaptive Illumination Mapping for Shadow Detection in Raw Images. We are from School of Information and Communication Engineering, Dalian University of Technology, and Department of Computer Science, City University of Hong Kong. Shadow detection methods rely on multi-scale contrasts, especially global contrast, information to locate shadows correctly. However, we observe that camera image signal processor tends to preserve more local contrast information by satisfying global contrast information during the raw to sRGB conversion process. This often causes existing matter to fall in the scenes with high global contrast but low local contrast in the shadow regions. As seen in this figure, when a non-shadow region has low contrast to the shadow region but high contrast to another non-shadow region. For example, the blue boundary of the objects. Existing methods may fail to detect the shadow region correctly. We propose to detect shadow in the raw images by learning the project's raw images into sRGB image of different intensity ranges adaptively. Our method can detect the shadow region correctly. We propose the first shadow raw dataset with 7019 raw images and the corresponding shadow mask for training and evaluation. The raw images are split into 6143 images for training and 876 images for test. Given a demonstrated 4-channel raw images, we first fed it to our adaptive illumination mapping model. This model produced 2 sRGB images of different intensity ranges. They are then contrasted with raw images and are fed into simple and effective shadow detection model to detect shadows. A feedback mechanism is proposed to train the AIM module to be shadow aware with diversity loss to avoid IS1 and IS2 being identical. To diversify the illumination, we propose the loss AIM to enhance and constrain output images as equation 1. We use mTOR to indicate the different intensity level on images, as it is a soft binary mask generated by a linearable threshold TOR on the luminous space Y of images as equation 1 and equation 2. The figure on the right gives a visualization of equation 1. It shows that AIM module learns to project raw images of sRGB into sRGB image of different intensity distribution. We conduct our experiments on our dataset as well as 3 existing sRGB image-based datasets. They are SBU, UCF, and ISTD, which demonstrate our advantage of using raw images for shadow detection. We also provide visual results